There are countless stars in the night sky that we observe, but the universe is much larger than what we can see with the human eye. In fact, the universe is so vast that we cannot see the majority of the far-off things. But certain items are so potent that we can still detect them despite their great distance from us, although only using telescopes. Quasars, or quasi-stellar radio sources, are what I'm referring to. Do you wish to be aware of their nature? Watch this video to learn more. It's fascinating to consider the history of the earliest sightings of quasars, which were initially made in the 1950s. Astronomers first began utilizing radio telescopes to observe the sky in the 1950s. In contrast to regular telescopes, radio telescopes look for radio waves rather than visible light. When astronomers first began using these tools to watch the sky, they were shocked to discover some objects releasing a significant amount of radio waves, but hardly any visible light. In actuality, the majority of these radio wave sources have nothing to do with any well-known visual objects. The oddly named 3C273, which corresponds to the 273rd object in the 3rd Cambridge Catalogue of Radio Sources, was the first quasar ever found. It was found because of a lunar occultation, which is an occurrence when the moon passes in front of an object and obscures it from our perspective. A team of astronomers from Cambridge University discovered the radio source 3C273 in the sky in 1959, but they were unable to locate its optical equivalent. A series of observations of the sky during which the moon was passing in front of the radio source found 3 years earlier were made possible by John Bolton and his Caltech Radio Astronomy group using the Parkes Radio Telescope 3 years later, in 1962. Bolton and his team were able to pinpoint the source's location with the help of these lunar occultations. More significantly, they were able to link it to a weak star counterpart that was observable. Later, fresh quasars were found. Typically speaking, their positions in the sky corresponded with very faint objects, such as very far-off stars. For this reason, they were given the name quasars, which is an abbreviation for quasi-stellar, star-like, and radio source. Yet, the chemical makeup of these objects, as shown by examining their spectral lines, differed greatly from that of any known star. Also, they were emitting too much radiation to be considered typical stars. Over the years, these quasars were still being observed. Scientists discovered that these objects were traveling very quickly and away from the Earth by studying the radiation spectrum of these particles. This could be deduced from the redshift phenomenon. Every celestial body produces radiation throughout a wide band of frequencies, including the visible spectrum, which is made up of the colors violet, blue, green, yellow, orange, and red. The frequency of the light that we see determines the color that our eyes perceive. Violet corresponds to the greatest frequency, while red corresponds to the lowest. While the light emitted by an object in the sky is composed of a variety of wavelengths, one color dominates the spectrum. In fact, if we gaze up at the sky, we can see that some stars appear red and others blue. Yet, our eyes perceive the frequency of the light emitted by an object differently when it is moving with respect to the Earth. Particularly if the item is traveling in our direction, the frequency of its light seems to rise, making it appear more blue in color, blue shift. Instead, the frequency of the object's light appears to drop as it moves away from us, making it appear more reddish. This is referred to as a red shift. Scientists discovered a significant redshift in the radiation spectrum of these quasars, which indicates that they were traveling away from Earth. Not only that, but they also learned how far away from us these objects were. The degree of redshift can also be used to derive this information. In reality, Edwin Hubble, a renowned astronomer, studied hundreds of galaxies in 1931 and found that their velocity was inversely correlated with their distance from the Earth. In other words, the more away and faster they were moving from us, the greater the redshift of the light originating from those galaxies. The Hubble's law, one of the most significant findings in astronomy, is what is known as this result. Scientists in the 1960s discovered by using Hubble's law that the quasars they were detecting had to have been very far away from the Earth, some of them even 10 to 20 billion light years away. As a result, quasars are now among the universe's most distant objects. After learning a little about the history of quasar observation, you might be wondering what quasars are. Before finding out more about quasars, please let us know if you like or dislike the video so we can keep enhancing and improving these movies for you. As some of these quasars were still visible while being quite far away from Earth, the key challenge in seeing them was to understand how they could produce such enormous amounts of energy. There were no established processes to account for that. Hence, scientists were unaware of the nature of these quasars. In 1964, Edwin Salpeter and Yakov Zeldovich put forth the explanation. They claimed that quasars were supermassive black holes around by vast quantities of matter. But, since light, and any other type of radiation, is truly unable to escape from a black hole, how are these things able to produce such massive amounts of light and energy? The energy of a quasar is really generated outside of the black hole, which explains why. A tremendous amount of matter is falling towards and rapidly rotating around the supermassive black hole. This stuff experiences extraordinarily intense friction as a result of the black hole's powerful gravitational pull, and as a result, it releases a significant amount of energy as various types of radiation, such as radio waves. The term accretion disk refers to the shape that this rotating debris assumes. When this stuff moves in the direction of the black hole, between 6% and 32% of its mass is transformed into energy, which is a significant amount of energy. Comparatively, our sun's nuclear processes only produce energy from less than 1% of its mass. Quasars are among the universe's most potent and energetic things. As a contrast, a quasar can emit an amount of energy comparable to 1,000 times the amount of energy emitted by the complete Milky Way, our galaxy. Despite this, quasars are too dim to be seen from Earth with conventional telescopes due to their extreme distance from us. But one of these quasars would shine 1 trillion times brighter than our star if we could position it at the same distance from Earth as the Sun. It's noteworthy to notice that quasars often have a small size despite their great luminosity. In actuality, quasars typically have a diameter of a few light years, and some of them may even be smaller than our solar system. For reference, the Milky Way is approximately 200,000 light years across. That makes a significant impact, as you can see. Quasars are a subset of the active galactic nucleus, AGN, family of objects, which is made up of all galactic cores with abnormal electromagnetic radiation emission that may be explained by the accretion disk mechanism. AGNs release X-rays, gamma rays, and other radiation types in addition to radio waves and visible light. The existence of relativistic jets is an intriguing phenomenon occasionally connected to quasars. While their exact origin is unknown, it is thought that they are the result of the accretion disk's interaction with the black hole's magnetic field. Under specific circumstances, this interaction results in jets of particles moving nearly as fast as light. These jets appear as two beams of incredibly energetic particles moving in opposition because they emerge from both poles of the black holes. They can span 1 million light years and are very bright, sometimes even brighter than the quasar itself. These relativistic jet-producing quasars are also referred to as blazars. You might be curious as to why these quasars are so far away from us. Are there any nearby quasars? The solution to this intriguing query has to do with the evolution of galaxies. Quasars are thought to have been more prevalent in the early universe. Quasars require a lot of material to create because they are highly active objects. For instance, when two galaxies collide, the black holes at their centers may merge, producing a supermassive black hole that might give rise to a quasar. Quasars can also emerge as a result of other events. Extreme events, like the collision of two galaxies, were considerably more likely to occur in the early universe because it was both smaller and denser than it is now. As a result, quasar formation occurred much more frequently than it does today. While matter continuously falling into the black hole, quasars burn a lot of energy extremely quickly due to their nature. This implies that the accretion disk is finite and that the majority of quasars have already consumed all the energy present. The fact that a celestial object's age and distance are related is another thing we need to keep in mind. In reality, it takes some time for an item's light to reach us. The further away the thing is from us, the longer it takes. Most quasars are currently extremely far away, even 10 or 20 billion light years away, which means that light takes 10 or 20 billion years to reach us because the universe is expanding continuously. This implies that we are actually seeing into the past and seeing quasars as they were 10 or 20 billion years ago. Very likely, the energy in these quasars has been used up, and they are no longer as bright. This explains why we typically don't observe quasars close to us. Also, it's possible that some of the galaxies we see now were once quasars. In fact, the huge black holes at the centers of the galaxies that we see today are also present. As a result, it's probable that in their early years, matter that was very close to the black hole underwent the accretion disk event that we previously described, but we no longer see it. In this respect, quasars can be thought of as the centers of newly formed galaxies. In fact, astronomers think that the Milky Way was once a quasar. Even nevertheless, this does not imply that quasars can no longer form. Even the Milky Way itself might someday host a brand new quasar. In fact, it is believed that the Milky Way and the Andromeda Galaxy will collide in roughly 4.5 billion years because they are now heading in the same direction. We must keep in mind that the supermassive black holes at the centers of both galaxies. These two black holes will therefore converge and interact in a devastating way when this enormous collision occurs. Extreme frictional forces will be exerted on the matter around these two monstrosities, creating a quasar or even a blazar. So, ultimately, this is the fate of our galaxy. Incredible, isn't it? And somehow quasars reflect both our past and our future. This video ends here. Thank you everybody for watching. Are quasars cool to you? Do you need to know anything else about them? Please let us know in the comments section below. Don't forget to subscribe, and I'll see you on the channel again soon.